This video is brought to you by the GCC and discusses results sections in robotics papers. As we read, we'll try to understand why the authors might have made certain decisions and what effect these choices might have on readers. Be sure to watch our video on the methods and design section before moving forward. We'll look at the same article that describes a robot inspired by a lizard's tail. As we've mentioned, this is a proof of concept paper, which differs a bit from the traditional or experimental paper. Specifically, the design section is the biggest and most newsworthy portion of a proof of concept paper, providing researchers with the main focus of the project. So, in these papers, the results section serves to validate the design, reporting how well the robot, algorithm, or method performed in a certain test, application, or user-based scenario. We'll structure this video in the same way that we did the design video, looking first at headings and organization, then at the content and language, and finally, the figures and tables. If your project follows a more traditional or experimental structure, be sure to mention this during your one-on-one GCC sessions. Nevertheless, most of these main principles will still apply, and the main difference will be the content that's included in the results section. Many of the learnable principles that we covered in the design video still hold for the results section, so you'll notice some overlap. First, in terms of headings and organization, you should still use headings and subheadings to strategically chunk your information. Of course, there's no rule for what you should name each heading, but in design papers, it's very common to see the results section labeled experimental results. Depending on what type of design your research is covering and how you're evaluating that design, you might consider different titles for the headings of your results section, such as user study or case studies or something more project specific. For subheadings, this paper uses general subheadings like experimental methods or simulation verification, as well as more experiment-specific subheadings like falling from a wall and completing transitions. If your design is in conversation with common tests performed in robotics, consider using some of that vocabulary in your headings and subheadings. That way, readers who are specifically interested in that type of content can easily find that information. Next, let's turn to content and language in the results section. First, as we discussed in the design video, robotics papers tend to use the first-person plural pronoun we in order to foreground the actions and decisions of the researchers. You'll notice this throughout the paper, but most prominently in the design and experimental results sections. In the design video, we talked about how the design section gives readers everything they need to know about how the robot works and why the researchers made the decisions that they did. For the results section, then, readers are looking for the application of the design, how it's being tested, and what those tests show. Here, the authors state, "We evaluated the effectiveness of our active tail by observing the robot's behavior in 3 simple representations of locomotory challenges: a fall, a large perturbation, and a transition between surfaces of greatly differing slopes." This is a direct statement telling the reader what they can expect in this section, and it helps give the readers the info they need to interpret the other subheadings as well as the content. So, be sure to include everything your reader needs to interpret the validity of your experiment. This includes the methods for the experiment, the procedure itself, and the results of the experiment. Here, the authors describe their method for calculating the results of the experiment before describing the 3 testing scenarios and the robot's performance in each. Because the design section contains the author's rationale for particular design choices, it's easy to see that this experiment is responding to certain research questions pertaining to the tail design and the robot's ability to reorient itself. If the scope of your project is much broader, or if you think readers might have a hard time making this connection, consider including your research questions at the beginning of your results section. Sometimes, you might even see researchers state their hypotheses, but again, this depends on the specific content of your project. Overall, in the experimental results section, the writing style remains mostly the same, And the authors open up each chunked section with similar explanations of why they are performing certain actions. For instance, the authors state, to verify the model's predictive ability, we performed a freefall test at maximum control effort and measured the time and tail stroke required to reorient the body 45 degrees. To test the ability of Tailbot to rapidly reorient itself in a fall with a zero net angular momentum turn. To test the ability of the active tail to help mitigate perturbations in a rapid locomotory task. And Figure 14 shows a task to evaluate the ability of Tailbot to transition between surfaces of significantly different slopes using an inertial maneuver. In each of these examples, the researchers are explicitly letting their readers know which aspect of Tailbot's performance they're evaluating with each experiment. They also justify their choice of specific falling procedures in their experiment and ultimately offer results that both comment and report on how their design performed. So, when reporting results, stick to the report and comment model, saving implications in future studies for the conclusion section. Of course, there are exceptions to this, and some researchers include these implications in their experimental results section if they have something to do with a very specific aspect of the design, like we see here. Given enough falling distance, this effect would further allow the tail to rotate away from the underbelly of the robot when landing. However, a future tail design should incorporate a selective flexibility at the tail base if landing on the tail became unavoidable. This type of suggestion makes sense since it applies to this very small portion of the report. You may also notice researchers suggest improvements to their design in the experimental results section whenever the design does not necessarily perform as expected. We see this toward the end of the experimental results section. By combining visual surveying with an inertial tail, a robot could use short aerial phases to smooth the transitions between uneven surfaces. Typically, the comments that do appear in the results section answer questions pertaining to the robot's performance of a specific task, while the broader implications for the field are reserved for the discussion section. For example, the authors state, we suspended the robot nose down, allowing the tail to hang passively, and released the robot. Tailbot righted itself in about one body length of drop distance and held the desired orientation until impact. The reader is given a description of the experiment and is also told how the robot performed in the experiment. We also see the researchers offer some practical rationale for the experiments themselves, stating, while Tailbot can self-right from the initial orientation in Figure 8, in a practical setting, the tail would likely be held approximately parallel to the body. Again, this is useful for helping your reader see exactly what aspect of your design's performance is being tested. Finally, let's turn to the figures and tables. The same basic learnable principles that we talked about in the design video also apply to the results section. Typically, the types of figures that you would expect to see in the results section help depict the experiment itself for the reader. Here, the authors offer diagrams of each experimental setup, as well as video stills that show the robot's performance. Other figures for different projects might include certain data visualizations used for analysis. Let's look at the caption for Figure 10. The robot attempts to regulate the body angle, but is unable to do so due to tail saturation. In B, when the robot is able to contact the wall and inject angular momentum into the system, saturation is avoided. With enough falling distance, the tail will rotate enough to avoid being landed upon. Not only do the researchers describe what's happening in the video stills and the experiment itself, they also offer the reader an interpretation of the robot's performance that fits with the types of problems that the design attempts to solve. Let's review our key observations and takeaways from the experimental results section. Use headings and subheadings to strategically chunk the information. Use the first-person pronoun we to foreground the actions and decisions of the researchers. Include the experimental methods, procedures, and results. Report and comment on your results, saving implications and future studies for your conclusion section. Remember that all figures and tables should be numbered, and that figures are numbered separately from tables. all figures and tables should be referenced in the body of the text. Captions should contain all of the information necessary to understand the figure or table. Once again, remember that your own projects will vary, and so will your writing. Try to use some of the reading strategies that you saw in this video when reading other articles and when revising your own papers. And remember, you can schedule an appointment with one of our tutors on the GCC's website.